Was the question?
No, the students are joining very late for the class. So like it is
Really
like
sorry,
going.
ma'am. It happened with me today alone because I had some network issues. I couldn't inform you, so I was 1 minute late. I'm really sorry.
No, not just your case. Generally, the whole class, I'm seeing slowly, everybody takes their own sweet time to join for the class. Mm. So everybody are under the assumption Golda ma'am will give attendance. So let's join at our own sweet time. Then finally, at the end of the hour, she will take attendance and we'll all give attendance. I think that thing should be stopped. I should take attendance at the beginning of the class and then stop with that. Okay, right. Anybody remembers which part of data mining we are doing right now? Asking this question with a hope to get some answer from someone. Hmm? Nobody remembers as usual. Did anybody get all the answers for the crossword? Hmm?
Not all, ma'am, but most of it. Most of it. One or
Most
two
of it.
left.
Okay, then I'll post it in the GCR. You put it as an assignment. You submit it as an assignment, all these. Okay, right. Let's proceed. Okay, so we were discussing about decision tree, the classification technique called decision tree. We discussed various algorithms also for decision tree. Hmm. What are the various algorithms we discussed? We discussed about ID3 algorithm, then C4.5, then uh, CART, correlation and regression tree, and we did the problems for all these. And I asked you to submit a problem as an assignment. So all these had happened. Okay. So before we move on to the next classification technique, so let us uh, discuss about another topic associated with the decision tree called uh, overfitting and tree pruning. Okay, overfitting and tree pruning. Okay, so have you heard? I mean, I heard of this terminology called overfitting. Overfitting, overfitting, and tree pruning. When do we call something as overfitting or overfitted? Hmm? Or why do we need to prune the tree? Prune means cut, chop off several branches or certain branches which is not reliable or not so good for some reason. We are removing them. Okay, so that's what is called pruning. Okay, so like when the decision tree is being built, how it is built we have already seen that. Okay, so many of the branches might reflect some anomalies in the training data. It could be due to noise or it could be due to some outliers. Okay, so the tree pruning methods will address the problem of overfitting the data. Now the question is, what is this overfitting? Anybody knows what is called overfitting? Hmm? When like anybody has done a course in machine learning or deep learning or
I think
yeah.
it is when a model fits
Hmm.
too much on the training data that it is unable to predict when future unknown data is coming to it.
Yes, very good. That's what. Okay. So when we train it with a lot of data, then we can
Train
say
it
that,
very well, right?
yeah, then we say that statistical model is said to be overfitted when we are training it with a lot of data. It's just like we are trying to fit into a oversized dress or whatever. Okay, so when a particular model is being trained with too much data, what happens is, I mean, it will start learning from whatever is there in the data. There could be noise, inaccurate data entries, and all those things will be there. Okay, so when it starts learning from all these anomalies, what will happen is the model will not be able to categorize or classify the data correctly, because there are too many details in it. Noise, outliers, and all these things are there. Okay, so that's the issue with overfitting. That's what is called overfitting. Okay, so this tree pruning methods, there are basically two tree pruning methods. One is what is called pre pruning, and second one is what is called post pruning. Okay, so these are basically two statistical measures which are used to remove the least reliable branches. Okay, so let's see what is this pre-pruning and what is this post-pruning. Pre-pruning and post-pruning. Okay, so okay, before coming to telling what I mean, reading out this and explaining, let me take an example. Okay, so you can see here a figure. This is straight from your textbook, Camber textbook, the standard book mentioned for you. Okay, so this is an unpruned decision tree, and this is the pruned version of it. So you can see that this pruned tree, it is much smaller, and it looks less complex too. Okay, so it is much more easier to comprehend compared to the other one. Okay, so I mean, so with the help of this pruned tree, you can deal with it in a little more faster pace, and you can correctly or very easily or quickly classify, mm, go perform the task of classification. Okay, so when compared to this unpruned tree. Okay, so this I just wanted to show you the difference between a pruned tree and a unpruned tree. Okay, so there are two approaches to pruning. One is what is called pre-pruning, and the second one is what is called post pruning. Pre-pruning and post pruning. Okay, so as the name suggests, pre-pruning. Okay, so pre-pruning is all about halt the tree construction early. Okay, that is uh, early stopping. Pre-pruning is all about early stopping. Early stopping. Okay, so you're stopping the tree before it has completely classified the training set. Okay, so that's what is pre-pruning about. Okay, so halt the tree construction early. Do not split a node if this would result in the goodness measure falling below a threshold value. Okay, so it's all about halting the tree construction early. So it is telling if the goodness if it would result in the goodness measure falling below a threshold. What is this goodness measure? What is this goodness measure? Can you name the goodness measures what you have learned? I'll feel really bad. What are the various goodness measures that you have learned when we discuss the various tree algorithms, decision tree algorithms? Hmm? Hmm? What are the goodness measures we learned? The various splitting criterions, what are they? We discussed about entropy or information gain, then gain ratio. This was for the second algorithm, that was C4.5. Then for CART, what did we use? Gini index. Yes, these are the goodness measures. Okay, so what it says is do not split a node if this would result in the goodness measure, one of these falling below a threshold. Okay, so if the partitioning of the tuple at some particular node, if it is going to result in a split that falls below a pre-specified threshold, you set the threshold value. If it is going below that, you stop further partitioning, or partitioning of the subset is halted. Okay, so of course there are difficulties involved. Okay, so in choosing an appropriate threshold and other things, but then this is one of the suggestions. Okay, because again, choosing an appropriate threshold itself is a big problem of research, or there are various aspects to be considered. Why? Because when you have very high threshold values, it could result in trees which are oversimplified. Okay, whereas if you select threshold values which are very small, that could result in little simplification. Okay, so all these can happen. Okay, so then you have what is called a post pruning. Post pruning. Okay, so remove branches from fully grown trees. Get a sequence of progressively pruned trees. Use a set of data different from the training data to decide which is the best pruned tree. Okay, so this is post pruning. Post pruning is removing the subtrees from a fully grown tree. Okay, so you can see here, you can see here in this picture. Okay. Okay, so this is a pruned tree. Okay. Okay, this is the pruned tree. So you can see here the node A3. Where is it? The node A3. Okay, so this is the node A3. Okay, so this is, I mean, node A3 in the unpruned tree. Okay, so let's suppose the most common class within this subtree. I'm considering this part. Okay, so I mean A3, class A3. So like the most common class within this subtree, which is the most common class within this subtree. Class B is coming once here, class B is coming twice here. So class B is the most common class. Okay, so what I'm doing is in the pruned version, I take a decision to replace all the subtrees. The subtree is, I mean, you replace it with the class B. Replace with class B. So I'm pruning it. Okay. So that's what happens here. That's one of the ways for pruning it. Okay. So you see which is the most common class. I find it as class B. So in the pruned version of the tree, the subtree in question is being pruned by replacing it with the leaf class B. Okay. So this becomes the leaf node and the most common one, class B. Okay. So this is one way of pruning it. Okay, so these are the two pruning strategies. One is pre-pruning and another one is post-pruning. Okay, so next, okay, these are all the enhancements which can be done to the basic decision tree. Okay, you can allow for continuous valued attributes, how to handle the missing attributes. You can assign the most common value or assign probability values, or even you can create new attributes based on the existing ones that are sparsely represented. Okay, so repetition, replication, and all those things has to be taken into consideration. Okay, so next coming to the scalability aspect. Scalability aspect. This comes into picture especially when you are planning to classify VLDBs, very large databases. Okay, so classification is a problem which is extensively studied by statisticians and ML researchers. The scalability, this is what we are going to discuss now. Okay, so classifying data sets with millions of examples and hundreds of attributes. Okay, how do we do this? Okay, so the reasons for popularity of a decision tree is being mentioned here. Relatively faster learning speed, it's convertible. You can use even SQL queries for accessing the databases. Okay, so now let's see what are the two techniques which can deal with very, I mean, classification of very large databases. One is actually rainforest, and the second one is what is called your boat algorithm. First is rainforest. Okay. Okay, so let's first see. Okay, the scalability framework being suggested by rainforest. Okay, so I said most of the data mining applications, we are not dealing with data sets which are having few hundreds of records. We are all in on a real time databases. They have very large training sets of millions of tuples. Okay, so many a times the training data will not even fit in the memory. Okay, so many a times your decision trees construction becomes very inefficient due to the swapping of the training tuples, swapping into the main memory to cache memory, or cache memory to main memory. All these things can affect the performance of decision trees. Okay, so it is very essential to have little more scalable approaches which can handle training data with billions of records, and which can fit into the memory, or which can take care of such aspects. Okay, so rainforest, the one which is being mentioned in the slide, is one such technique. Okay, so rainforest basically adapts to the amount of main memory whatever is available, and applies to any decision tree induction technique. Okay, so this rainforest, what it does is it maintains what is called a, you can see here, AVC list. It maintains what is called an AVC list. So AVC stands for attribute value class label. Attribute value class label. Yeah, this one, AVC. Class label for each attribute. Okay, for each attribute at each uh, node of the tree. Okay, so whatever is describing the training tuples in that particular node. Okay, so you can see here the ABC set and it's being grouped. So I mean, rather than going through these definitions, to make you clear, I'll give you an example of what this AVC is all about. AVC is all about aggregation. Okay, so you can see here, this is, you have attributes: age, income, student, credit rating, which will determine whether the person will buy a computer or not. Okay, so I'm constructing an AVC set for age. AVC set for age. So you can see here, age is having, these are the domain values available. So that can be aggregated as less than or equal to 30, 31 to 40, greater than 40. These are the three distinct values which are available in the record. Okay, so then based on this, you make the decision, yes and no, and you can count how many, less than or equal to 30, how many records are there which says yes, how many are there which is no, greater than 40, how many yes, how many no. Okay, similarly do for all the attributes. That's what is called your AVC set. Okay, AVC set, which stands for attribute value class label. Attribute value and class label. Okay, so for income, income, there are three distinct values: high, medium and low. Okay, so student, yes and no. Credit rating, fake, fair and excellent. Okay, so that's what. So this is how rainforest takes care of the scalability. Okay, so it's you can say it's making use of a data structure to hold the aggregate information regarding the training data. Okay, so aggregate, it's a data structure which will hold the aggregate information and then ensure that it fits in the memory. Okay, so this is one way of handling very large databases. Okay, so then another technique is what is called bootstrapped optimistic algorithm. Okay, it's called BOAT, bootstrapped optimistic algorithm. So this BOAT is, it's basically a statistical technique called bootstrapping. Okay, so the second half of this unit will be discussing about various techniques for improving improving the efficiency of the classification technique, where we will be discussing about bootstrapping in detail. Okay, so as of now, keep in mind, this is BOAT, that is bootstrapped optimistic algorithm, is used to create several smaller subsets, each which will fit in the memory. Okay, so this is not, it doesn't make use of any special data structure. Okay, it is not like previously AVC set was a special data structure, okay, which was holding the aggregate value of each of the attribute. Out here, BOAT is not holding any special data structure. Okay, so instead, it is basically making use of a statistical technique known as bootstrapping, to create several smaller samples, or subsets of the given training data. Okay, and each of that will fit into the memory. Okay, so each subset is used to construct a tree. Okay, so which will, in turn will result in several trees. Okay, so the trees are being examined and used to construct a newer tree. You can see here that particular tree is being examined and it's used to construct a new tree, T dash. Okay, and that T dash turns out to be very close to the tree that would have been generated if all the original training data had fit into the memory. Okay, so approximation. Okay, so BOAT can use actually any attribute selection measure, okay, that selects binary split. And that is purely based on the notion of purity of partition. Purity, we had discussed about purity of split and other things. Entropy, purity of split, information gain, okay, Gini index, and all those things. Okay, so the main advantage is, yeah, this BOAT It requires only 2 scans of database. And it's basically a incremental algorithm. Okay, so you can see here. So the BOAT uses the lower bound on the attribute selection measure to detect very good trees. Let's say T dash, how it is different from the real tree, T. Okay, that which was generated using all the data. Okay, so T dash is from the subset, and T is from the original. Okay, so it will keep on refining that T dash in order to create your T. Okay, so T dash is from the subset and T is from the original tree. Okay, so as a result of this, BOAT requires only 2 scans of the data. Okay, so this is actually a very big improvement, because the other decision tree algorithms, whatever we have learned, all the basic algorithms require multiple scanning. Basically, one scan at each tree level. Okay, so as a result, your this bootstrapped optimistic algorithm is actually much more faster when compared to your rainforest also, while constructing exactly the same tree. Okay, so then it is also called an incremental algorithm. Okay, so that is another aspect. Okay, so these are the two scalability frameworks which are suggested for decision trees for handling very large data. Okay, one is what is called your rainforest, which maintains what is called an ABC set, a special data structure which holds the aggregates. And the second one is about a technique called bootstrapping. Okay, you're creating several smaller samples. Okay, and those are used to construct what is called a T dash. You see how much of an approximation of T dash is with respect to T, which is being created from the entire large training data. And then um, you proceed with it. Okay, so and this the main advantage is it requires only 2 scans of the database, whereas the other one required multiple scans. Okay, so with that we come to an end of the first classification technique called decision trees. Okay, so these are the presentation of classification results using various tools and softwares. So this is using dbminer. uh, okay, one of the classes I will show you a demonstration using your Colab, Python and Colab. Okay, so the classification technique, this is using SGI Miner Mindset 3. This is a perception based classification. Okay, right, I can just show you this as of now. Okay, these are the various papers and other things, the techniques, the scalable decision tree methods. Those who are interested in going one step ahead in understanding this can look through this. We had discussed these two, rainforest and BOAT. Okay, there are others too, Sprint, SLIQ, public, and various things are there. Okay, so these are the different techniques. Okay, so next we need to, so we have completed these two. We discussed about the basic classification concepts, the decision tree induction by discussing ID3, C4.5, CART, and today about pruning, pruning the tree to improve the efficiency, pre-pruning and pre and post-pruning. Then the scalability aspect of decision tree. Scalability aspect. So that completes your decision tree. So next we need to move on to what is called Bayes classification methods. Okay, Bayes classification method, or this comes under the heading called probability based learning technique. Probability based learning technique. So when we say probability based, are you all listening or sleeping? Anybody listening? Only
Yes,
one
ma'am.
person. Abilal Patel and Anirudh only are listening. Sriram, listening?
Yes, ma'am.
Okay, then who else? Which other name is there coming to my mouth? Srimati, 46.
Yes, ma'am. Yes, ma'am.
Yes, yes. Okay, Praveen, 149. Listening?
Yes, ma'am.
Okay. Rakesh is there in the class or absent? 171. As usual, you are absent or planning to come at the end to take attendance. Hmm? Hiten there in class?
Yes, ma'am.
Okay. So Rakesh is not there. Okay, let's come back. Okay, so Bayes classification methods said it's all a part of probability-based learning technique, wherein we have two things to be considered. One is what is called a probabilistic model, and the second one is what is called the deterministic model. Okay, so actually this is one of the most like significant practical learning method, this probability learning method. It combines two things, what is called prior knowledge or prior probability. Prior knowledge or prior probability with the observed data. Okay, so like this probability learning, when you say probability learning, the thing that comes to your mind is all about the concept of uh, probability theory. I mean, how to model randomness, uncertainty, noise, how to model all these things to predict the future events. Okay, so that's what probability learning is all about. Okay, so I mean, you can say it's a technique or a tool for modeling a large data sets, and basically makes use of your Bayes rule to infer your unknown quantities or to make a future prediction. Okay, so as far as a probability model is concerned, it is randomness which plays a major role, which gives the probability distribution a solution. But then if you see this deterministic model, the second one, deterministic model, there is no randomness associated with it. Okay, so no randomness associated with it, in the sense it will exhibit the same condition, the same initial condition every time the model is being run. And you are likely to get the same single possible outcome as a solution, as far as a deterministic model is being considered. Okay, fine. So why, I mean, I'll give you an example scenario to understand where exactly this probability based learning, Bayes theorem, etc., should be used. Okay, so let's consider, I'll give you an example. Let's consider a task. Okay, we want to predict the occurrence of a particular individual having a liver illness or a liver problem. Okay, so that is based on that particular individual's eating habit and how efficiently he works and his working efficiency. Okay, so that is I want to predict the occurrence of an individual's liver illness based on two factors. One is eating habit, and second one is work efficiency. Okay, so what is the general perception? Okay, so we are aware that most of the people who eat healthy, and exercise consistently, they have less probability of uh, contracting your liver illness or liver cirrhosis or whatever. Okay, but then this liver cirrhosis or liver problem can be due to some other issue also, some other factors also. For example, if that particular person, though he, I mean, it can be due to he is having a lot of, let's say, high calorie food, like some junk food or some street food, and he is continuously using alcohol. Okay, so that could be another reason for it. Okay, so determining whether an individual's eating routine is healthy or the workout efficiency is sufficient, so that is also subject to analysis, which in turn may introduce so many anomalies or vulnerabilities into the leaning issue, or whether the person is thin or fat and all those things. Okay, so there are numerous such applications. Okay, so the connection between the attribute set and the class variable is actually non-deterministic here. Okay, or in better words, or in simple words, we can say that the class label cannot be assumed with certainty, even though the circumstances may, there are attributes that is having enough and more training examples and other things. Okay, so that could, the uncertainties could be due to let's say the noisy data, or it could be due to the presence of some confusing factors, what I just told you. Okay, that could influence the classification. Okay, but then that is not being induced in the analysis or not being considered in the analysis. Okay, so in such cases we will have to go for what is called your probabilistic learning. Okay, so your probabilistic learning technique, so we have what is called the Bayesian learning. Okay, so Bayesian learning, actually it is little bit different from the ordinary probabilistic classification or learning, because it basically makes use of what is called as subjective probabilities. Okay, so subjective probability means the probability that can be based on an individual's belief. So based on that, we have what is called the Bayesian belief network. Belief network. Okay, so the probability can be based on individual's belief or interpretation about the outcome of an event, and how it can change over the time. Okay, so all these can be used to infer the parameters of a model. Okay, so there are basically two practical algorithms. One is what is called your Naive Bayes learning or classifier, NBC, classification, Naive Bayes Naive Bayes classifier learning, and the second one is what is called Bayesian belief network. Okay, so these are the two major parts of Bayesian learning. These are the two major parts of Bayesian learning. Okay, so when we say this Bayesian learning, all of you would have heard what is called your Bayes theorem. Okay, so this basically makes use of this Bayesian classification or Bayes classification, makes use of Bayes theorem to predict the occurrence of any event. Okay, you can see here the foundation is it's based on Bayes theorem. Okay, so to predict the occurrence of any event. Okay, so they are all basically statistical classifiers with the Bayesian probability understandings. That is how a level of belief can be expressed as a probability. Okay, so that's what the theorem tells, how a level of belief can be expressed as a probability. Okay, so these algorithms or techniques uses what is called the concept of what is called prior probabilities. I'll tell you what is prior probability, posterior probability, or conditional probability, and apply what is called your Bayes rule, Bayes theorem, to infer certain information. Okay, so certain certain information is given here. It's mentioned it's a statistical classifier. Foundation is based on Bayes theorem. Okay, incremental learning. Okay, so first let's look into the foundations for it. I said the foundation for Bayesian classifier is nothing but your Bayes theorem. Bayes theorem. So let's look at what this Bayes theorem tells, or what are the foundations as fundamental aspects of Bayes theorem. Okay, so the Bayes theorem basically works on three kinds of probabilities. Three kinds of probability. The first one is what is called the prior probability. The second one is what is called the likelihood probability. And the third one is what is called the posterior probability or conditional probability. Okay, this is the first one, second one, third one. Oh, okay, fine. Okay, so what is prior probability? What does prior probability represent? Okay, so this prior probability, what it represents, what is originally believed before a particular new evidence is being introduced. Okay, so this posterior probability will always make use of what is called your prior probability, or your conditional probability will always make use of what is called your prior probability. Okay, so what is originally believed? I think the definition is not given here. Okay, I'll write what is originally believed before new evidence is introduced. Before new evidence is introduced. Okay, so Yeah, that's what is prior probability. Then the next one is likelihood probability. Likelihood probability. So probability of falling under a specific class or category. Specific class or category. Probability of falling under a specific class or category is what is called a likelihood probability. Okay, or you can say the relative probability of the observation occurring for each class, or the sampling density, for the given evidence given, for the evidence given the particular hypothesis. Okay, so these are all statistical definitions. Okay, so you represent it as, I think I missed out the PPT here. Okay, it is mentioned as probability of evidence given the hypothesis. Okay. Likeliness of the occurrence of the evidence given the parameters. Okay, that is what is likelihood probability. Okay, so then we have what is called the conditional probability or posterior probability. Okay, so always the posterior probability is equal to prior probability plus the likelihood probability. Likelihood probability or the new evidence or whatever. Okay, that's what is your posterior probability. That is, it is represented as hypothesis given the evidence. Your posterior probability. Okay, belief about the hypothesis. Belief about the hypothesis given the evidence from the training data. Okay, I'll give you an example. For example, let's say the historical data is suggesting that around 60% of the students who start college will graduate in 4 years. 60% of the people are graduating in, let's say, 4 years. Okay, so this is actually the prior probability. Okay, so before collecting the evidence, I am telling that from the historical data that 60% of the students who start the college or who start doing engineering will graduate with 4 years. So that's what is your prior probability. But then you think that the figure is actually much lower. So you actually set out to collect evidence or new data. Okay, so the evidence what you collect suggests that the true figure is actually close to 50%. 50% is actually the true figure. Okay, so this is actually the posterior probability. Posterior probability. Okay, so yeah. So this is this Bayes theorem or the Bayes rule is actually used to determine the posterior probability. Posterior probability given the prior probability of the event. Given the prior probability of the event. So this is the formula for it. H by X. Okay, or okay, so H given X is equal to the probability of X given H into probability of H divided by probability of X. Okay, so this P of H and P of X, okay, so they are called marginal probabilities. These two are called marginal probabilities. Okay, so this is this H given X or X given H. This is called a conditional probability. conditional probability. It is also called posterior probability. Posterior probability. Okay, so this P of H, P of X, so they are actually marginal probabilities of event H and event B. Event X occurring together. Okay, so this is the conditional probability or posterior probability. Okay, let me take attendance. Okay, are everybody listening or sleeping after connecting?
Listening, ma'am.
Listening. Okay, thank you, Aviral. At least one person is responding.
Listening, ma'am.
Okay, good. Okay, now let's see. I'll wake everybody up with attendance. Anirudh.
Then, ma'am.
Okay, let me reduce the volume. Dharani.
Present, ma'am.
Dharani is feeling very sleepy. Am I right?
No, ma'am.
No. Were you writing something, noting down something, whatever I was doing?
Yes, ma'am.
Okay, then good. Ram Harini.
Present, ma'am.
Yes. Kalyan Sundar.
Present, ma'am.
Aravind.
Present, ma'am.
Sharan Varghese. Okay, Sharan Varghese has texted, is it? Okay, Sharan. Shakti Priya.
Present, ma'am.
Nishok.
Present, ma'am.
Shreya.
Present, ma'am.
Suveda.
Present, ma'am.
Vishal Bhashyam.
Present, ma'am.
M. Srimati.
Present, ma'am.
Kamini Nityashri.
Yes, ma'am.
Pranav Ram.
Present, ma'am.
Srimati S.
Present, ma'am.
Raja Singh.
Present, ma'am.
Pooja.
Yes, ma'am.
Lavanya. Lavanya is sleeping or absent?
Absent, ma'am.
Absent. Okay, then no issues. S. Nityashri.
Present, ma'am.
Sriram.
Present, ma'am.
Likita.
Present, ma'am.
Satyamohan.
Present, ma'am.
Satyamohan, what topic were we discussing in the class today?
Ma'am, we were discussing about overfitting and pruning, ma'am. You have
After
seen Bayesian classifications and all.
Okay, fine, good. Sharan, S. Sharan.
Present, ma'am.
Aviral Patel.
Present, ma'am.
Hemavartini.
Present, ma'am.
Ajay.
Present, ma'am.
Akshata Saha.
Chat box, ma'am.
Fine, noted. Karthik Balaji. Karthik. Okay, noted. Santosh Kumar.
Yes, ma'am. Present, ma'am.
Anand. Noted. Anand Arun. 115. No attendance. Absent. Rahul. Okay, noted. Suhasini Srikanth.
Present, ma'am.
Apurva Ravichandran. Apurva, okay, present. Vitun.
Present, ma'am.
Adityan.
Present, ma'am.
Selva Niklesh.
Present, ma'am.
Ram Sharan.
Chat box, ma'am.
Okay, Achinta Murari.
Present, ma'am.
Ram Charan was absent for past 2 classes, sir. 122. What happened? Not well. Or you felt like taking a break? Don't be absent for class. That too online class. Santosh Kumar.
Present, ma'am.
Pavitra Shri.
Yes, ma'am.
Praveen.
Present, ma'am.
Rakesh. Okay, so Rakesh is actually absent. Nityashri Narasimhan.
Present, ma'am.
Nishok Kadiraven. Nishok. Okay, noted. Abel Prashant. Noted. Abel Prashant. Abel.
Present, ma'am.
Okay, Preetika is chat box. Kevin Kurian
Present, ma'am.
Joseph.
Present, ma'am.
Okay. Everybody are giving attendance and immediately leaving, huh? We have another 5 more minutes, I suppose. Okay, 45 Hitain.
Present, ma'am.
51 Adya.
Present, ma'am.
Jay Vora.
Yes, ma'am.
Kishore.
Present, ma'am.
Sridevi.
Present, ma'am.
Yash Rai. No, okay, noted. Jayesh Kumar. Okay, Jayesh. Anybody who has missed the attendance? No one. Okay, we'll continue with the later portions in the next class. You just make a note of this Bayes theorem. Bayes theorem, how to compute the posterior probabilities using Bayes theorem. See, P of H is what is called the P of H. You can see here, prior probability, the initial probability. X, for example, X will buy a computer regardless of age, income, etc. Okay, so P of X is the probability that the sample data is being observed. Okay, so P of X given H. Okay, so that is actually the likelihood, the probability of observing the sample X given the hypothesis holds. Okay, so the given that X will buy a computer, the probability that X is in the age group 31 to 40 with medium income. Okay, so that what is the likelihood of him buying the computer? Okay, so it's what? Okay, so those who have noted down, can you just give a try to whether you can solve this problem using Bayes theorem or not? I will do detailedly, but I just want to make I just want you to give a try to do this. Can you give a try?
Ma'am, 171 chat box, ma'am.
Who, Rakesh? Today no attendance. Rakesh is 171, right? In the beginning of the class, I called out for him. He was not there in class. Now when I was taking attendance, he was not there. So that time itself I was telling he will come at the end to ask attendance. Today, sorry Rakesh, no attendance for you. I'm observing you right from the beginning of the class. There are others too, but then I don't become too very strict. But then there are certain things that should be looked into. Okay, so no attendance for you. Okay, so just give a try to how to solve this problem. A spam assassin works as a mail filter to identify the spam in which users train the system. So in email, it considers patterns in words which are marked as spam by users. For example, it may have learned that the word release is marked as spam in 30% of email. Okay, that's one data to be taken. This one. Okay, then concluding 0.8% of non-spam mails, which include the word release, and 40% of all the emails which are received by the user is spam. Find the probability that a mail is spam if the word release seems in it. Those who have made a note of the Bayes theorem, can you just give a try? We will do it in tomorrow's class. Or just make a note of it with these data. Okay, right. Anyway, time is up. I don't want to continue further. We'll do it tomorrow. So today's class, we discussed about the pruning techniques, the pruning methodologies, and then we started looking into the next classification technique called probability-based learning. That is all about Bayes theorem. Okay, right. Thank you.